Welcome to part 3 of our presentation on inverter types and considerations. And in this part, I'm going to talk a little bit about module level power electronics. So when I say module level power electronics, I'm talking mostly about microinverters and DC to DC converters. And they're called module level power electronics because they are installed at the module level. They're installed physically where the modules themselves that they're connected to are installed. So generally with this type of equipment, we're going to see one or two modules connected to each device. So for example, one module, maybe two modules connected to a single microinverter or DC to DC converter. There may be cases where you can do more modules to a device, but it's going to depend on the equipment itself. So typically we're going to see one or two, and that allows us to really get the benefits of this type of equipment. So these devices can be integrated into a module at the factory level, so they may be manufactured as kind of an assembly at the module manufacturing factory, wherever that's being done, or they could be externally connected in the field to the module frames themselves or to the rails or racking to which the modules are also connected. And so one of the benefits of this type of equipment is that it provides module level maximum power point tracking. And this is a huge advantage in areas with a lot of shading. It's also a huge advantage on a rooftop where you might have a lot of different orientations of different roof planes. So this can help to minimize the effects of multiple orientations. It also can be helpful if you have different types of modules on a single array. So for instance, if you have to do a replacement of a module down the line, it might be easier to do that in a system that's using MLPE versus a system that's a string inverter system, because in this case with module level maximum power point tracking, these modules are essentially functioning independently of the other modules in the array. So one module that has shading impact, for instance, isn't going to bring down the performance of the other modules that are not shaded. So this is a huge advantage in a lot of different scenarios. One of the other benefits to this type of equipment is that the manufacturers of these units usually will have a really good module level data monitoring systems. So you can usually subscribe to those systems, log into your account, and you can view the real-time performance of the equipment in the field as it's happening. Microinverters specifically are available for different AC output voltages, and that's useful because you can use them in commercial or residential settings in different size systems from very small up to very large system sizes. Their ease of replacement can be an issue depending on the location within the array. So if you have, two rows of modules in an array, that can be fairly easy to get to all those modules. If you have a very densely packed, very large array on a roof, for example, it may be much more challenging to access any of the modules sort of in the middle of that array, because that means you're going to have to take away the exterior, the outer modules, to get to whatever's in the middle part of that array. And so that can be an issue with modules or the module level power electronic devices. If you have a module that's failed or is not working in the middle of an array, or if you have a microinverter or a DC to DC converter that has failed in the middle of an array, it's going to be much more difficult to get to than something along the outside edges of the array. So keeping in mind ease of replacement when you're designing an array system with these types of equipment. One other point of consideration with this type of equipment is that they offer multiple points of failure, and this can be a good or a bad thing. If you have, for some reason, a bunch of inverters or microinverters or DC to DC converters that go offline or don't work or something have an issue, then you have multiple places where there can be issues that have to be dealt with, and they might not always be the same issues. So you might be troubleshooting an array with different problems on different inverters, different microinverters or something along those lines, and that can make it a little more complicated for troubleshooting. But it can also be a good thing, because if you just have one microinverter that happens to fail, it's not going to impact necessarily the performance of your entire system. And so you may have a situation where one microinverter will fail, and that may still mean that part of your system can continue to function unaffected. Another nice feature of this type of equipment is that they are typically pretty small. They're easily handled. They don't weigh a lot. They aren't very big. They don't take up a lot of space. They're easy to ship. They're easy to deliver, and they're easy to work with. Whereas larger string inverters, for example, can be heavy. You might need two people to hang one on a wall, and you might need a crane if it's a larger central inverter, which we'll talk a little bit more about in a little bit. But anyway, these are pretty easy to manage, and that makes it a huge advantage for installation. Let's take a look now at a typical microinverter configuration. And what you can see in the diagram is we have one PV module connected to a single microinverter, and those microinverters are connected together in parallel. So keeping in mind that microinverters are going to have AC output, and so the AC output of each microinverter is connected in parallel in a single circuit, so within a single circuit. And typically we're going to have multiple circuits of microinverters connected in parallel to increase your system size. So you might have one circuit of 10, and then you might decide you want one circuit of 8, and that's totally acceptable depending on the actual equipment itself. You might have any variety of different number of microinverters connected in parallel in a single circuit, but depending on the manufacturer and the model of that equipment, there will probably be a maximum number that you can connect in parallel per the manufacturer. So that's a limitation that you'll want to check out. Microinverters are typically limited to a certain number in parallel per circuit. So that would be either in the installation manual or on the data sheet, the specification sheet. And typically with these kinds of things, you're going to have one or more modules connected to each inverter. So 1 or 2 is most common. There could be more depending on the equipment. Comparing microinverters then to DC converters, we have a little bit different of a situation. So it looks pretty similar in the way that they're connected here and the way they're shown, but we have some pretty significant differences that's important to be aware of. So we still have, in this case, we're showing one PV module connected to one DC converter, but the DC converters are connected in series. So these have DC output, and these are connected in series to form a series string. Very similar to a typical string inverter configuration. They also require an additional inverter to actually make the system function. So whereas microinverters are the inverters themselves, DC converters are units that will connect in series to form a series string that you then connect to its inverter. So what we see here is that these kind of converters modulate DC output depending on the inverter that they're connected to. Some DC converters can be purchased individually and used with any different type of an inverter from a different manufacturer, but you have to make sure that if you're going to do that you are using equipment that's compatible with each other. Some DC converters are required to function with an inverter that's made by the same manufacturer. So make sure in this case and in every case that any equipment that you're using together is rated and is compatible to work together. So depending on the manufacturer and the model of converter that you're using, there will probably be a maximum number that you're allowed to connect in series. That also will be found either on the specification sheet or in the installation manual for that converter. And we're usually going to see one or more modules connected to each converter. 1 or 2 is most common. Sometimes there could be 3, maybe more, depending on the equipment. And then you can have a single series string, or you might have multiple series strings connected to each inverter that you are using. So the important takeaway here, just to know, kind of as a quick recap, is that DC to DC converters will have a DC output versus microinverters which have an AC output. And so that's kind of the big thing to keep aware of when you're using this equipment. And DC to DC converters have to connect to their own inverter, whereas microinverters are their own independent functioning inverters. So just some of the differences between the two types of systems. That's the end of part 3. Take a break and come back and join us for part 4 when you're ready. I'll be talking about string inverters.